Thanks. I'm Paul Bonorden. I'm the Rotating Machinery Capability Manager for INVISTA. INVISTA is a maker of nylon intermediates that are used in many of the products that you use today. INVISTA is part of Koch Industries, which has been a leader of innovation for over 80 years. Koch is always challenging us. Let's see, I'll figure this clicker thing. Okay. Koch is always challenging us to be a leader and implement new innovative technologies in our processes. Okay, the story I'm going to tell you is a journey over the last 18 months. We started looking at the forest of trees, trying to find our path to the other side. There are many opportunities to choose from in this day and age. Many have been attempted with marginal success. Our group tried to focus on one main goal, and as we were climbing this tree, being aware of all the low-hanging fruit that we could grab along the way. The most important thing is not let the fruit get in the way of climbing the tree. All right, we feel that predictive analytics is the tree that will be beneficial to increasing our reliability and productivity at our sites. Having a better understanding of the process variables and how they interact with each other would be a game changer for us. Our processes are complicated and the interactions are not always apparent. To get started, we looked at our sister companies to learn from their predictive analytics pilots. There were several initiated with mixed results. But the biggest learning we saw was the importance of having data and lots of it. The most important successful pilot at one of our sister companies started with 5 years worth of uncompressed data. Currently at our sites, we only keep 12 months of data, of which 3 months are uncompressed. We realized in order to get successful outcomes from predictive analytics, we needed more data. The first step we took was to just turn off data compression at all our sites. The next step was to figure out how we're going to store more data. We looked at adding more servers and storing data in the cloud. Each has its pros and cons. The servers require capital outlay and resources to maintain them. The cloud storage has its issue with security and intellectual property. We ended up doing a mix of both. So now that we were storing the data that we already had, we needed to focus on getting the data we need. Okay, from a mechanical point of view, we knew that predictive analytics needed more vibration data. We have wired vibration systems on a small percentage of our equipment, but the balance of plant only had vibration data collected from handheld data collectors. At the most, this was once a month. This handheld vibration data does not have the resolution required for predictive analytics. Installing a wired system on the balance of plant would be cost prohibitive. It typically costs at least 10 times the amount to install a wired sensor as compared to a wireless one. Our first step was to compare the major players in the wireless vibration market. There's many out there. We looked at various attributes of the systems, such as range, sensor type, sensitivity, protocols, electrical classification, and power source. The cost was also evaluated for the hardware, the software, the installation, and the recurring charges. Several attributes varied widely. With the batteries, for instance, they varied from CR123, D cells, C cells, proprietary, with different costs and availabilities. The item that really stood out to us was the protocols. This was going to be a problem trying to integrate with all the other initiatives at the plant. We knew that it did not make sense to install a wireless network that would only be good for wireless vibration. Remember that predictive analytics is our primary goal. It requires data from other sources other than vibration sensors. We surveyed the instrument, electrical, fixed equipment, and process groups to determine what other types of sensors they would be using and determine what kind of protocols they utilized. These included pressures, temperatures, flows, electrical, voltage and current, and even corrosion monitoring. ISA 100 and YHART were the dominant protocols used in the industry. INVISTA then developed a Wi-Fi standard based on these learnings and started to construct a series of wireless networks at our major sites. This wireless standard also included Wi-Fi so that personnel in the field could utilize tablets. All right, this is where we stopped and took a pause and said, okay, we know what path we're going down. How are we going to capitalize this? Where is that other low-hanging fruit we could grab? So we developed a division for the future. This was a time that we can ensure the changes that we would implement would get the maximum benefit. With the implementation of wireless data collecting, we know that routine route-based collection would be significantly reduced or even eliminated. This would free up approximately 50% of vibration technicians' time, thus enabling more time for higher value-adding work. Our PM activities could then be moved from a time-based to condition-based. The technicians could then spend the extra time looking at real-time data to identify problems earlier. INVISTA has multiple sites across the globe. Each has its own group of vibration technicians that work in a silo with little outside influence. The new mental model is to have these technicians collaborate with each other. To facilitate this, software platforms will need to be consolidated across the sites. All right. We then looked at our sister companies again for the existing use of wireless vibration sensors. One of them had an installation that did a really good job of indicating changes and trends in vibration levels. One of the major learnings from their sensors was the amount of unknown transient events that were occurring at their site. A pump would run cavitated, deadheaded, or off the curve for short periods of time, and no one was aware. This will prematurely wear out a pump. This pump might have had a 40-month mean time between failure, but if the transient events could be eliminated, it could easily jump to a 60-month MTBF for that piece of equipment. I visited with the vibration technicians at the site, and they told me the software that came with the sensors could not easily identify the root cause of the increased vibration. They still had to go out and take a set of readings with a handheld device to diagnose the problem. This could be a software issue, but most likely it was due to the sensor's capabilities. They were MEM sensors, and the dynamic bandwidth and data frequency is less than that of a piezoelectric. A MEM sensor is a popular sensor. It is compact. It is even used in every modern cell phone. In its defense, in a year or two, it may equal or exceed that of a piezoelectric. But now that we had the information that we needed, it was decided that the Bentley system was the best for our installation. There were several key factors that we used in this decision. One, we felt that it was important that we own the data. Several companies move the data off-site for analysis. We needed to use this data for more than vibration analysis. Remember, predictive analytics is our goal. The System 1 software, along with their Ranger sensors, could diagnose specific equipment failure modes. Vibration technician could then use System 1 software along with other OPC data imported into System 1, such as tank levels, pressures, temperatures, to construct a data package that would automatically send a notification to a specific operator with tactical instructions on what they needed to do to correct a vibration event. System 1 incorporates wireless, wired, and portable vibration data, thus allowing the vibration technicians across different sites to collaborate and work more efficiently. The Bentley system does have the highest upfront cost, but when we looked at the 5 and 10 years amortized costs, they are about 50% of the cost of their competitors. They've been responsive to our customer feedback and improvement requests. I'm going to put them on the spot here. Remember, our primary goal is to collect data for predictive analytics. It requires more frequent data than once every 15 minutes that the Ranger Pro collects. I've been speaking to them about implementing a wake-up function in their Rangers so that if a signal varies more than a set amount, it would wake up and send the data right away. The DCS can be programmed to copy that last data point received if a new value does not come in. That way, the data resolution will be consistent and we'll be able to catch transient events. This timestamp is also critical for predictive analytics. I'm told that this will be in the next software update. The last item is hard to quantify on a spreadsheet, but Bentley has decade-long track record in the vibration industry and is sure to be there providing development and support for decades to come. In conclusion, remember, the brass ring that we are trying to grab is the utilization of predictive analytics. Predictive analytics is not an easy endeavor. There are many software packages out there that perform the data crunching, but it still takes a skilled and knowledgeable technician to gather the data and interpret the results. A vibration technician, in my opinion, is uniquely skilled for this task. They are usually experienced mechanics to start with, they understand failure modes, and have experience working with operators to troubleshoot equipment issues. This is where having the group working collectively will really pay off. I see individuals becoming specialized on equipment types and taking their learnings and leverage it across their site and others. Over time, I'm sure as predictive analytics becomes more mainstream, that this will change as well. At that time, we will embrace the next innovation technology. Thanks.